Alright, I'm back, hello world, and we're going to continue watching WWDC sessions, and next up is Meet Distributed Actors in Swift. And quick reminder how this works, so I'm not going to show the video or the audio, just a small thumbnail so you see where I'm at. And you have to open the session on the second screen if you want to watch alongside me. I'm going to count down from 3 and say when I click play, so you can click play at the same time. Now we can watch alongside each other. I'm going to be taking notes, and after the session I'm going to go through my notes and basically give my opinion on the whole session and how I see that, and basically a summary of that. If you want to skip the watch along, just skip to the end of the video and just watch the last few minutes for my reaction. Alright, so I have to quickly download this and set up everything. Let's turn off the music. And I think we are ready, so get ready, and I'm counting down 3, 2, 1, play. All right, that was a session, but I have to write this to the end because this is very interesting. So we have sample WebSocket actor system. WebSocket actor system available in Swift NIO. We have local networking actor system. Oh no, it's not available in making use of Swift NIO. Making use sample, making use of Bonjour, and full-fledged Swift dist. Oh no, this is full-fledged, fully featured server-side cluster library in the making, beta. All right. So that was Meet Distributed Actors, and let me turn on the music here. Great. So what have you learned, and what is my key takeaway? Meet Distributed Actors, so they started with like kind of an introduction. They basically told us that we should think of actors, like not just distributed actors, but even actors. We should think of them as islands. So they're always independent from each other, and within their island, they basically control everything, and then you can send things to other islands. They say that this is a very useful mental model, and they call it the sea of concurrency. All right, so you can see here a C distribution example where two players are basically playing a game on two different devices or two different processes, two different servers, whatever. That really doesn't matter. But yeah, they have some data, a main actor and player, and again a main actor and player, and they can exchange data, and the data exchanges automatically by an actor system. So the actor system is basically that the encapsulating the complicated part of networking. That's basically how that works. Like the messaging happens in the actor system, and there can be different kinds of actor systems, and there will be reference implementations, and I'm sure there will be also open source implementations and things like that. But that's basically how it works. You always have to provide an actor system. And we already summarized the ones available. The one actor system that ships with the library is local testing distributed actor system, which helps you like basically test it locally. Then they also presented two use cases where which code you can find online on Apple on basically this session's sample code. One is for when you use a WebSocket to communicate via internet, and one is if you want to do a local networking kind of game. And then the full-fledged one, it's still in beta, but that will be coming out later, sometime, probably later this year or the beginning of next year, I'm guessing. All right, so as you can see, you can play around. You can basically, they showed like different use cases. So if you really want to see the code for a specific one, watch the session and just play to the play part that you need. They started with an offline play, so they could show the test distributed actor system. Then playing against the remote AI, so you actually had to use one, and they used the local testing. This is the local testing one. So there's nothing to be sent through the network, so that's where the local system one does work. And interestingly, they said that when you have to basically switch from an actor system to a distributed actor system, you can no longer provide an ID in your actor. Instead, you're using something called an actor identity that is basically then created for you and exchanged and looked up for you. I'm guessing in the actor system. An actor system is something you need to provide. This is a type alias you need to provide on each type that is a distributed actor, as far as I saw that at least in the code. And of course, these data types need to be codable or some other serializable type. If your actor system uses, I don't know, serializable or some other way of communicating data and putting it into a specific serialization form, then you can use that. But codable makes sense most, I think. And then, yeah, they went into different examples. I'm not going to go into the details of the code here, but yeah, what maybe interestingly, they showed that the server side, like basically the player's side, just when playing with an opponent, if they're not creating the player on the device, but they're basically expecting there to be a player from somewhere else, they're just requesting the player with an ID. And it can be an exact ID. Like if you want to play in a local network, you need to have like a discovery system. That's what the last example was about. Or the 1-2 last example was about. If you need a discovery system where you can find the IDs. I imagine something like you're searching for the Wi-Fi networks in your area, and then you see their SSIDs and the name of the Wi-Fi networks. And that's probably how it works here as well, where you see the player IDs that are available to play right now. And then you choose one of them and then you request like, okay, I need that player now. And the other way is if you're playing with basically, I think that was a local network example, they could just say, okay, I request this random ID if you're playing against a bot, for example. And then in any case, the server has to resolve the create command. So it recognizes if the ID is already available, maybe it looks it up on the database, I don't know, something like that. And then when it's not available, the server then creates it and then sends it over. So on the player side, you just request an object, an actor with an ID. That's basically how it works. It's, of course, we need more examples to really understand how it works, but yeah, try wait all around. They basically gave us more like guidance in how we could implement our own. I think it's really important that there will be some example projects actually implementing this whole stuff. So I'm looking forward to the open source community to maybe bring out something and write articles how this was built to really see how this works. Because yeah, just with this session, I think it's just an introduction and there's still a lot to learn here. And that's it from my side about this session. So meet distributed actors in Swift. Thank you for joining in. If you're watching this on YouTube, make sure to like the video right now. And I'll be having a quick break. And after the break, we're continuing with use Xcode to develop a multi-platform app. All right, looking forward to that. And I'll be right back.